Ladies and gentlemen, we are meeting today with a new video of the Engineering in Amharic YouTube channel series. 1.1 Methods of creating the model. There are two methods of creating the structure data. 1. Using the Graphical Model Generation Mode, or Graphical User Interface, GUI, as it is typically referred to. 2. Using the command file. The command file is a text file which contains the data for the structure being modeled. This file consists of simple English language-like commands. This command file may be created directly using the editor built into the program, or for that matter, any editor which saves data in text form, e.g., Notepad, TextPad, Notepad++, etc. This command file is also automatically created behind the scenes when the structure is generated using the graphical user interface. The graphical model generation mode and the command file are seamlessly integrated. So, at any time, you may temporarily exit the graphical model generation mode and access the command file. You will find that it reflects all data entered through the graphical model generation mode. Further, when you make changes to the command file and save it, the GUI immediately reflects the changes made to the structure through the command file. Both methods of creating our model are explained in this tutorial. Sections 1.3 through 1.6 explain the procedure for creating the file using the GUI. Section 1.7 describes creation of the command file using the STAAD-Pro text editor. 1.2 Description of the tutorial problem. The structure for this project is a single bay, single-story steel portal frame that will be analyzed and designed. The figure below shows the structure. Figure 2:1, Portal Frame Model. An input file called tut01portal.std containing the input data for the above structure has been provided with the program. This file contains what would otherwise have resulted had we followed the procedure explained in section 1.7. Basic data for the structure attribute data member properties members 1 and 3, W12x35. Member 2, W14x34 material constants modulus of elasticity, 29000 ksi. Poisson's ratio, 0.30 member offset 6.0 inches along global X for member 2 at both ends supports node 1, fixed. Node 4, pinned loads load case 1, dead plus live. Beam 2:2, 5 kips per foot downward along global Y. Load case 2, wind from left. 10 kips point force at node 2. Load case 3 to 75% of DL plus LL plus WL. Load combination L1 by 0.75 plus L2 by 0.75 analysis type linear elastic. Perform. Steel design consider load cases 1 and 3 only. Parameters. Unsupported length of compression flange for bending. 10 feet for members 2 and 3, 15 feet for member 1. Steel yield stress, 40 ksi. Perform member selection for members 2 and 3. The STAAD-Pro window displaying the start screen. Note about the unit system. There are two base unit systems in the program which control the unit's length, force, temperature, etc., in which values, specifically results and other information presented in the tables and reports, are displayed in. The base unit system also dictates what type of default values the program will use when attributes such as modulus of elasticity, density, etc., are assigned based on material types, steel, concrete, aluminum, selected from the program's library. Please refer to Section 5 of the STAAD-Pro Technical Reference Manual for details. These two unit systems are English foot, pound, etc., and metric kn, meter, etc. If you recall, one of the choices made at the time of installing STAAD-Pro is this base unit system setting. That choice will serve as the default until we specifically change it. We can change this setting either by going to the File greater than Configure menu or by selecting Configuration under Project Tasks. In the dialog that comes up, choose the appropriate unit system you want. For this tutorial, let us choose the English units KIP, feet, etc. Open the Configure Program dialog. Click Accept to close the dialog. 1.4 Creating a new structure. In the new dialog, we provide some crucial initial data necessary for building the model. 1. Select File greater than New. Or select New Project under Project Tasks. The new dialog opens. The structure type is defined as either space, plane, floor, or truss. Space the structure, the loading or both, cause the structure to deform in all three global axes X, Y and Z. Plane the geometry, loading and deformation are restricted to the global XY plane only. Floor. A structure whose geometry is confined to the XZ plane. Truss the structure carries loading by pure axial action. Truss members are deemed incapable of carrying shear, bending and torsion. 2. Select plane. 3. Select foot as the length unit and kilo-pound as the force unit. The units can be changed later, if necessary, at any stage of the model creation. 4. Specify the file name as portal and specify a location where the STAAD input file will be located on your computer or network. You can directly type a file path or click to open the Browse by Folder dialog, which is used to select a location using a Windows file tree. After specifying the above input, click Next. The next page of the wizard, Where do you want to go, opens. In the Where do you want to go dialog, we choose the tools to be used to initially construct the model. Add beam, add plate, or add solid. Respectively, the tools selected for you used in constructing beams, plates, or solids when the GUI opens. Open Structure Wizard. Provides access to a library of structural templates which the program comes equipped with. Those template models can be extracted and modified parametrically to arrive at our model geometry or some of its parts. Open STAAD Editor. Used to be create a model using the STAAD command language in the STAAD Editor. All these options are also available from the menus and dialogues of the GUI, even after we dismiss this dialog. If you wish to use the editor to create the model, choose Open STAAD Editor, click Finish, and proceed to section 1.7. 5. Select the Add Beam option and click Finish. The dialog will be dismissed and the STAAD-Pro graphical environment will be displayed. 1.5 Creating the model using the graphical user interface. It is helpful to take some time to familiarize yourself with the components of the STAAD-Pro window. A sample of the STAAD-Pro window is shown in the following figure. The window has 5 major elements as described below. Elements of the STAAD-Pro window. A. Menu bar. Located at the top of the screen, the menu bar gives access to all the facilities of STAAD-Pro. B. Toolbar. The dockable toolbar gives access to the most frequently used commands. You may also create your own customized toolbar. C. Main window. This is the largest area at the center of the screen, where the model drawings and results are displayed in pictorial form. D. Page control. The page control is a set of tabs that appear on the leftmost part of the screen. Each tab on the page control allows you to perform specific tasks. The organization of the pages, from top to bottom, represents the logical sequence of operations, such as definition of beans, specification of member properties, loading, and so on. Each tab has a name and an icon for easy identification. The name on the tabs may or may not appear depending on your screen resolution and the size of the STAAD-Pro window. However, the icons on the page control tabs always appear. The pages in the page control area depend on the mode of operation. The mode of operation may be set from the mode menu from the menu bar. Data area. The right side of the screen is called the data area, where different dialogues, tables, list boxes, etc. appear depending on the type of operation you are performing. For example, when you select the geometry beam page, the data area contains the node coordinate table and the member incidence table. When you are in the load page, the contents of the data area changes to display the currently assigned load cases and the icons for different types of loads. The icons in the toolbar as well as in the page control area offer tooltip help. As we move the mouse pointer over a button, the name of the button, called a tooltip, appears above or below the button. This floating tooltip help will identify the icon. A brief description of the icon also appears in the status bar. We are now ready to start building the model geometry. The steps and, wherever possible, the corresponding STAAD-Pro commands. The instructions which get written in the STAAD input file are described in the following sections.
Thank you for watching.